Gilbert Green is not an ordinary storm chaser. A software engineering major at Florida Gulf Coast University who is also minoring in physics and mathematics, Green spent the summer of 2022 in Florida chasing and photographing lightning.
I recorded daily from around 1 to 3 hours a day, depending on the storm systems that were over the state. And I attempted to record and document as many lightning events as I could. I would say in the hundreds, a few hundred to possibly 1,000 lightning events over the course of the summer.
It may not be the wisest, but it is an easy thing to do since in 2021, Florida recorded over 18.7 million lightning flashes. It's what brought visiting physics professor Dr. Naomi Watanabe and her research to FGCU.
Lightning is fascinating and beautiful, but dangerous natural phenomenon. And also, it's abundant in Florida. And so we have a lot of opportunity to observe lightning activities.
So over the course of the summer, I believe I recorded 5 different types of lightning. This includes cloud to ground, cloud to cloud, ground to cloud, intracloud, and spider lightning.
It is the very rare spider lightning that brought Dr. Watanabe and Green together for further research at FGCU. Part of the team's research is to determine how spider lightning develops and its potential importance in meteorology.
They are very powerful lightning events. They're stunning as compared to just a cloud to ground. They don't pose as much risk as other types, although they are sometimes associated with cloud to ground strikes. And these can extend 20 miles. One example, I know that there was a lightning event in Cape Coral that extended all the way to Bonita Springs. So they can be rather fantastic when you do see them.
We are in the process of investigating how meteorological conditions, for example, air temperature, pressure, wind speed, intensity, or precipitation, other kind of conditions, how these meteorological conditions initiate spider lightning.
And this typically, for spider lightning, occurs at night. So the combination of reduced solar energy and this storm interacting with the Gulf Coast starts to cause the storm to decay. And so from the decay, this causes stratified clouds, which are basically chopped up clouds that distribute over the area. And this may cause some imbalances in the electromagnetic fields. The storms that actually produce lightning in the first place have to be somewhat powerful to do that. So if we can see a correlation in more quantity of lightning strikes from this summer as compared to a previous summer and one in the future, we can infer that in the future there should be a higher quantity of lightning strikes with the increase in precipitation that we're seeing in the atmosphere.
Watanabe and Green hope to publish their spider lightning research in spring 2023. Green also intends to graduate in May with even loftier goals.
After I graduate, I'm hoping to work at NOAA, and one of the jobs that I am currently applying for is to work with a satellite that will be looking at space weather and specifically solar weather, so weather from the sun specifically.